Hello everyone, welcome to A1 Tutor Live class, the physics session. Welcome to A1 Tutor Live class, and right away we are going to be having physics. Our last class in physics, we started a new topic which is work, energy, and power. Work, energy, and power. And the last class we treated work, and today we are taking the next one, which is energy. Energy. Today we are taking the next one, which is what? Energy. If we are to define the definition of energy, the simple definition of energy is the ability to do work. Energy is the ability to do work. Energy is the ability to do work. So the ability you have as a person to do a work is said to be energy. And energy is not just talking about a man, but it's talking about different things that we have around us. Okay, it's talking about different things that we have around us. Let's take this scenario. What actually brings about us having light? What is responsible for light is what we call light energy. So there's an energy that is responsible for us to have light. Okay, and light makes vision possible. I believe we all know that light makes visions possible. So energy is the ability to do work. Energy in physics is classified to be a scalar quantity. Energy is classified to be a scalar quantity, and energy is measured in joules, which is represented by letter J. Energy is measured in joule, which is represented by letter J. So to start with, we are going to start with the definition of energy. Then after we move to the forms of energy that we have. The forms of energy that we have. Okay, let's start with the definition of energy. The definition of energy. All right, the definition of energy, as we said earlier, the definition of energy. Energy is defined as the ability to do work. Energy is defined as the ability to do work, and energy is a scalar quantity, which is measured in joules, So the ability to do work is referred to as energy. So the ability for a man to work is referred as energy, and that energy is actually gotten from somewhere. For a man, energy is derived from the food we eat. So from the food we eat, we get what we call chemical energy. We get chemical energy from the food we eat, which serve as the strength for us to do work. Okay, so that is what we call energy, the ability to do work. The ability to do work. So if you have energy as a person, definitely you'll be strong enough and you will fit enough to do some certain work. So energy is the ability to do work. All right, so we have different forms of energy. We have different forms of energy, which we are going to consider. We are going to consider one after the other. And for the sake of those forms of energy, for us to understand it very well, I'm going to make use of some pictures to explain the forms of energy that we have and also cite the examples of those forms of energy. So let's consider those pictures. The forms of energy that we have. The forms of energy. So we are going to make use of pictures to explain them. So the pictures are loading. We are going to have access to the pictures through our chat box. Then we are going to consider each of those pictures to explain the forms of energy. So we have many forms of energy, and we're going to list out the ones we have here. The forms of energy we have in physics. Nine forms of energy. We're going to be taking them one after the other. So we have the first four here, the first four forms of energy. Forms of energy. We have the first form of energy, which is mechanical energy. Mechanical energy. The energy due to motion or position is said to be mechanical energy. The energy due to motion or position is said to be mechanical energy. The energy due to motion or position. So when we have an energy that has to do with position or motion, it is classified to be under the mechanical energy. All right, it's classified to be under the mechanical energy. Okay, we can have some examples of those mechanical energy. Let's consider some of the example of mechanical energy. Now, considering this diagram, here we have categories of mechanical energy. Mechanical energy is subdivided into two, which is the potential energy and the kinetic energy. The potential energy and the kinetic energy. This is potential energy, and these are the kinetic energy. Potential energy has to do with objects in motion in position, while kinetic has to do with the energy in motion. So the energy in position is called potential energy, and the energy in motion is called the kinetic energy. All right, so here we have the first example of mechanical energy under the one that are classified to be potential. We have a car on a hill, a car on a hill. So you can see the picture here that we have a car that is on its own position on the hill. The car is not moving actually, it's static. Okay, so this car is maintaining its position, is static. So it is classified to be a what? A potential energy. And that is an example of what? Mechanical energy. Okay, we have apple on the tree also. The apple on the tree has what we call a mechanical energy. A mechanical energy because it has an energy at the position where is what is maintaining. Okay, so we have a boy, okay, a bowl being pulled, a bowl being pulled. Now, what we call a bowl is this thing is being pulled, but it has not been released into the space. So when it is being pulled, at that moment, it is static or it is in position, not in motion. So it is classified to be a mechanical energy, and it is under a potential energy because it is still maintaining its position until the ball is released into the space before it becomes an object that have a kinetic energy, because kinetic energy deals with what? Energy in motion. Energy in motion. Now let's consider the ones of kinetic energy still under mechanical energy. We have a windmill rotating. A windmill what? Rotating is what? A mechanical energy, and is classified to be a kinetic energy. We have a boy on a skateboarding. A boy on a skateboarding. So the boy is actually in motion, and that is why the boy possesses a what? A kinetic energy. Okay, we have another one, a woman cycling. A woman cycling also is a mechanical energy classified to be a kinetic energy because it is an energy that is under motion, okay? An energy that is observed in motion is said to be a what? A kinetic energy. So we have two categories under mechanical energy. One is the potential energy and the other is the kinetic energy. Potential energy has to do with energy observed in position, while kinetic energy has to do with energy observed in what? In motion. So there are two different things. I believe that is clear to us. If you can hear me and you are following me, please kindly signify. Do you have access to the pictures I sent to the chat box? If yes, please kindly signify, and let's proceed to the next form of energy. So if you can hear me, please kindly signify thumbs up. If you can hear me, please thumbs up, and let's continue the class. I want to be sure that you can hear me. Okay, all right. So can you also have an access to the pictures in the chat box? Do you have access to those pictures? If yes, please kindly signify. So we proceed. Okay, all right. So let's move to the next form of energy. So we'll stop presenting this picture and move to the next one. The next form of energy we have is what we call the thermal energy. The thermal energy. The heat energy from particles movements. The heat energy from particle movement. So thermal energy has to do with heat energy. Thermal energy has to do with what? Heat energy. Okay? Has to do with heat energy. So we classify any form of energy that generates heat to be a thermal energy. To be a what? A thermal energy. Okay? So let's look at those examples of thermal energy that we have. Let's consider some example of thermal energy that we have. Thermal energy, energies that generate heat, are said to be thermal energy. So let's consider some of them. So let's consider this presentation. These are examples of thermal energy that are very close to us, related to us. So here we have a stove, and it is said to have a what? A thermal energy. Why? Because it has to do with heat energy. It has to do with what? Heat energy. So a stove is a good example of what? Thermal energy. We have the iron also. Is also a good example of what? Thermal energy, because it also generates heat. It also generates heat. We also have the heater, also is a good example of what? Thermal energy. We have the microwave oven. The microwave oven is also an example of what? Thermal energy. We have the toaster also is an example of thermal energy. We have the fireplace. This also is an example of what? Thermal energy. All right, so thermal energy are energy that what? That generates heat. Okay, and all these gadgets that we've mentioned here, they all generate heat. So we classify them to be under thermal energy. We classify them to be under thermal energy. Okay, so that's the second form of what? Of energy that we have. We'll move on to the next form of energy. The next form of energy is called the chemical energy. The chemical energy. Energy stored in chemical bonds released in what? In reaction. Energy stored in what? Chemical bonds released in what? In reaction. A very good example of chemical energy is something that we actually relate with every day. That is food. In our food, we have chemical energy. So the energy that we get from our food is what is classified to be a chemical energy. A chemical energy. Let's cite more examples of chemical energy so we can relate with them. More examples of chemical energy that we have. So looking at this diagram, we have examples of chemical energy here. Examples of what? Chemical energy. We have a battery. In a battery, what we have there is also called a chemical energy because the battery is made up of chemicals. Okay, it's made up of what? Chemicals. So it has a chemical energy. We have the gasoline, also a product of chemicals. So it has a chemical energy. We have the coal. The coal also is a chemical energy. The food, like I mentioned earlier, the food we consume also have some constituents of chemicals. And that is why we also have the food to be a perfect examples of what? Chemical energy. We have the natural gas is also a good example of what? Chemical energy. Explosive. Explosive also are examples of what? Chemical energy. Explosive used for probably some military people, by some military people, are being manufactured using chemicals. So they possess chemical energy. They possess chemical energy. If you are with me and you are actually following, please thumbs up. If you can hear me and you are following me, thumbs up as we continue with the forms of energy. Okay, thank you, Abdulhab. So we'll proceed to the next form of energy. We have the next form of energy to be electrical energy. Energy from the movement of electrons. Take note, electrons. Energy from the movement of what? Electrons. And a good example is the battery powering our smartphone. Your smartphone always has a battery inside, and if you check the battery, you try to put it on your tongue, you will see that there's a shock. So there's a shock because there are electrons present in that battery. Okay, and those electrons produce what we call the what? Electrical energy, and that is why you have access to power on your phone and use it for a moment. Okay, so let's consider other examples of chemical energy that are very related to us. Example of chemical energy, we have this picture is a TV. Of course, it has to do with what? Chemical energy. Because you can't make use of the TV without making use of what we call electricity. You need electricity to what? To power your what? Your TV. Your computer tablet also requires chemical energy to function very well. Your refrigerator in the house requires chemical energy. So all these examples, your video games also, okay, your video games also require chemical energy. So they work with chemical energy to perform their what? Their work. The microwave, yes, the microwave. You need to connect the microwave to an electricity socket before it can function, before it can perform its own work. So it's also a good example of chemical energy. The washing machine also is an example of what? Of electrical energy, of electrical energy. Okay, we are discussing here example of gadgets in the house that actually make use of electrical energy. And we also have the washing machine. We have the what? The alarm clock. The alarm clock. Some alarm clock also request or require that you connect them to the source of what? Electricity for it to work perfectly. We have electric scooter. So this also request or required that it is connected to what? An electrical source before it can what? It can function. So all these are examples of what? Electrical energy that are very closer to us that we can relate with. I believe you get that. So the examples of what? Electrical energy. So we'll move on to the next one. The next form of energy, we said we have 9 and we've discussed 4. We have 5 more to discuss. So let's take the remaining 5 that we have. We are still discussing the form of energy, the forms of energy. Okay, we have number 5 now. Forms of energy. So we have the fifth one to be the nuclear energy. The nuclear energy. The energy stored in atomic nuclear. The energy stored in atomic nuclear. So the energy in an atom is said to be a what? A nuclear energy. The energy in an atom is said to be the nuclear energy. An example of that is energy from a nuclear plant. Okay, from a nuclear plant, we can have what we call the nuclear energy. The next one is the solar energy, which has to do with our light, which is the sun, the natural light, which is the sun. The energy obtained from the sun is said to be a solar energy. The energy obtained from an ultraviolet light or radiation is also a solar energy. But the major example is the sun. So the energy we gain from the sun is said to be what? A nuclear, is said to be a solar energy. And that can be represented in this picture. Examples of solar energy that we have the natural ones, which are the natural light, and we have the artificial one. Okay, so the natural one, you can see we have the sun. The sun is what? A solar energy. The stars also are what? Classified to be what? Under solar energy. The fireflies. The fireflies is an insect that gives light while even flying. So it's also classified to be a what? A solar energy. Okay, and we have the natural source of what? Of light. Now these ones here can be classified under light energy. The candle is an example of the light energy. The lamp is an example of the light energy. And also the bulb is an example of what? The light energy. Because we have light energy, we have the solar energy. The solar energy is obtained from the sun. Is obtained from the sun. While the light energy is obtained from artificial source like the candle, the lamp, the bulb, and so on and so forth. All those ones are classified to be what? The light energy. But the energy extracted or the energy we gain from the sun is said to be the solar energy. The solar energy. Okay, so we move on to the next form of energy. We've discussed the light also, the light energy. We also have the sound energy. The sound energy carried, the sound energy are energy carried by vibrating waves through a medium. Sound carried by what? Vibrating waves through a medium. So we have vibrating waves that are carried through a medium. They are classified to be sound energy. When you listen to a sound, it's actually that there are vibrating waves that brings the sound to your hearing. So those vibrating waves are classified to be as what? Sound energy. An example is music playing from a speaker. When you move closer to a speaker, or even when you are far from the speaker, the vibrating waves transfer the sounds to you. So what we are actually receiving is the sound from the speaker. So the speaker is said to have what we call the sound energy. The sound energy. And I have some pictures here to depict that. Sound energy. Okay, so the energy we derive from all these examples, the train, when the train is moving, it makes some sound. Okay, on the rails, there are some sounds that it produces. That's the sound energy. Also, when the plane is flying, it also gives some sound. That is sound energy. When the lion is roaring, it also gives some sound and is also classified to be what? A sound energy. An example of what? Sound energy. The alarm, when the alarm is what? Is ringing, it also gives a sound. Okay, musical instrument also gives sound. The guitar, the drums, and so on and so forth, they give what? Sound. They are also what? Sound energy. The radio also gives us sound, and they are also what? Sound energy. So all these are examples of what? Sound energy. The example of sound energy. Let's move on to the last form of energy that we have here, which is what? The magnetic energy. Energy in a magnetic what? Field. Energy in a magnetic what? Field are said to be what? A magnetic what? Energy. And we have so many examples of it that we are very close to. A good example is our refrigerator. Our refrigerator also has what we call the magnetic energy. And that is why the door, when you open a refrigerator, you can close it. Okay? There's also a functionality of magnets in the refrigerator. In the close and open process of a refrigerator, there's magnets there. And that is what? Magnetic energy. All right? So we have so many examples. We have our earphone. Our earphone also is an example of what? Magnetic energy. If you are very inquisitive and you actually dismantle your earphone, you will see inside it that there's a speaker that has magnets attached to it. Okay, attached to it. We also have the loudspeaker, the same thing. We have a normal magnet also. The normal magnets also here has magnetic energy. We have the refrigerator. We have the train also. The train also possesses a magnetic energy, including the generator. All these examples are what? Good examples of what? Magnetic energy. Okay, if you are with me, please, and you are following, kindly signify. Are you getting the forms of energy so that we can proceed? If you are clear with the forms of energy, please signify so we can proceed to the next subtopic under the topic we are treating today. I need your response. Can we proceed to the next? If you are getting what we are doing here. You've gotten the explanation to the forms of energy. Please kindly signify by giving a thumbs up so we can move on to the next subtopic for today's class. I'm waiting for our reactions or our response in the chat box. Waiting for your response. If you understand the forms of energy we've just discussed, please kindly signify so we can move on. Okay, Abiola, thanks for your response. So let's move on to the next subtopic that we have here. So we are going to be talking now about the types of energy. That is, we have renewable and non-renewable energy. They are classified to be the source of energy. The source of energy. Source of energy. So now we are going to consider the sources of energy that we have. We have two sources of energy, which is renewable and non-renewable. Okay, so we'll proceed with the sources of energy, which are classified into two. The two sources of energy we have is renewable and non-renewable. So what is renewable energy? Renewable energy can be replaced and will not run out soon. Okay, so I use this simple way of explaining to you so that you can understand. Renewable energy are energy that can be renewed, that can be replaced, and they do not actually reach the stage of being exhausted totally. No, they are renewable and they are replaceable. So they continue to exist. They'll continue to exist over time. Renewable energy continue to exist over time. And a good example of renewable energy is the solar energy, which comes from the what? The sun. The solar energy, which comes from the sun, is a good example of what? Renewable energy. Like you know that solar energy are used as a source of electricity in Nigeria. Okay, we use them for electricity. We use them to produce electricity for home use, offices, and so on and so forth using a panel, which I'm going to share with us, the picture of how it looks like. Now, what we have here is a renewable energy. Now, this is a solar panel, of course. And this here, we have the sun. So the sun is a good example of a renewable energy. Now, the sun supplies energy to this panel to produce electricity. And over time, it continues like that. So we can never exhaust renewable energy. They what? They always exist over time. Over time. So they are replaceable. When we think we have exhausted, you notice that the energy again is still available for use. So the sun is not something we can exhaust. So it's a good example of what? A renewable energy. So we get the electricity from the sun, the radiation of the sun to the panel, and that process continues like that over time. And that is why we said sun, the solar energy, is said to be what? A good example of renewable energy. Okay, so let's proceed with our notes. The solar energy is a good example of renewable energy. Another one is also the wind. The wind is also a good example of renewable energy. A good example of renewable energy. Now, what do we call non-renewable energy? Energy that will finish one day. It's as simple as that. Energy that will finish one day and that cannot be replaced, quickly, are said to be what? Non-renewable energy. Okay? Energy that will finish one day and that cannot be replaced quickly are said to be non-renewable energy. Example of it is the fossil fuel. A fossil fuel is an example of non-renewable energy because the fossil fuel can finish one day, and to replace it, it might not be as soon as possible. The coal also, okay? We also have the petrol and the diesel. We are very familiar with this. If you have a petrol in your car, or probably you get fuel for the car and you drive the car for a while, it will get to a time that you exhaust the whole fuel. So you need to go back again and get another fuel. So energy that can finish, okay, are said to be non-renewable energy. Energy that can finish are said to be non-renewable energy. We have also the natural gas for cooking. If you keep on cooking every day in the house, a day is coming that you have nothing to cook again. You have nothing inside the cylinder to cook. You have no gas inside your cylinder to cook anymore. So that means you have exhausted the natural gas inside the cylinder. So you need to get another one. So energy that can finish one day are classified to be non-renewable energy. I believe that is clear to us. If that is clear to us, please let's signify. We are moving on. We are moving on to the next. If you understand what the sources of energy are, please kindly signify so that we'll move on to the next. And if you have questions, kindly drop your questions in the chat box and we are going to attend to it together. Waiting for your reactions, we want to move on to the next, which is conservation of energy. Is the sources of energy clear to us? If yes, please kindly signify. Signify with thumbs up or your favorite emoji. Is the sources of energy, is it clear to us? If yes, type yes in the chat box or thumbs up, and let's have the next subtopic. Okay, so we can proceed to the next subtopic. Okay, thank you, Abdulhab, for your response. So we'll move on to the next subtopic. Permit me to clean the board. Okay, now we want to consider what we call the law of conservation of energy. I'm very sure we are familiar with this from our secondary school, probably GSS in your basic science. The law of energy conservation is what we want to consider. The law states that energy cannot be created nor destroyed. Energy cannot be created or destroyed. It can only be changed from one form to the other. Energy cannot be created or destroyed. It can only be changed from one form to the other. This means that the total energy in a system remains the same, but it can be converted from one type to the other. It can be converted from one type to the other. Energy cannot be what? Created. We cannot create energy. And we cannot also destroy energy. But it can only be converted or it can be changed from one form of energy to the other form of energy. Okay, from one form of energy to the other form of energy. For example, from our food, we have a chemical energy in the food. After eating the food, we can work, all right? We can do some work. And while we are working, we are performing what we call mechanical energy. So you can see that from one form, which is chemical, we are able to what? Change the energy to what? Mechanical. Okay, so energy is transformed or is converted from one form to the other. Okay, from one form to the other. Let's consider some example on that. How energy are being converted from one form to the other. Now let's consider this presentation. We have electrical energy, right? When you plug this, you have this energy here, which is sound and light. You are plugging to electrical energy, and in your TV, you are getting a sound energy and a light energy. Okay, you plug to electrical energy and you are getting sound and light energy. From our generator here, we have a mechanical energy. All right, we have a mechanical energy which will also be converted to electrical energy. That is the bulb in the house. We will light up the bulb through the what? The functionality of our generator. And the generator has a mechanical energy which has been converted to electrical energy in the house. And we have our bulb that are already what? Lights. They are already what? Having their light displaying already. The same electrical energy will be used to power some gadgets in the house like the TV, the radio, the deck, and so many things in the house. So energy are not destroyed and they are not created, but they are just converted or they are changed from a form to the other. Okay, so look at this. Now we have the toaster. Is an electrical gadget. It has electrical energy, but what it is producing is called thermal heat. So from electrical energy, we have the thermal heat, the thermal energy, which is also what? The heat energy. So electrical energy has been converted to thermal energy. In this case, we have food. I said it the other time that the energy in our food is chemical. The chemical energy has been what? Converted to mechanical energy. And that is why the man is able to what? To be riding this bicycle. That is why the man is able to be riding this bicycle. So from chemical energy to what? Mechanical energy. So these are what? The process that explains how energy is being converted from one form to the other. From one form to the other. I believe that is clear to us. So let's move on to the next thing on our outline. So we have talked about the law of conservation of energy, and we have been able to consider energy transformation from one form to the other. Now let's consider the two types of mechanical energy that we have, which is the kinetic energy and the what? The potential energy. The kinetic energy, which is Ke, and the what? The potential energy. These two energy are classified to be mechanical energy. They are classified to be mechanical energy. Kinetic energy is the energy in motion, while potential energy is the energy in position. Okay, the energy in position. So this will take us to the calculation under energy. We can have some calculations under energy that has to do with potential energy and the kinetic energy. Kinetic energy is expressed mathematically as Ke equals to 1 over 2 mv squared, while potential energy is Pe equals to mgh, where under kinetic energy, m equals to mass and always measured in what? Kilogram, and v equals to velocity measured in meter per seconds, and under potential energy, m also equals to mass and g equals to acceleration due to gravity, and h equals to height. H equals to what? Height. So these two formula are going to be used to solve questions on what? On energy. Okay, they are going to be used to solve questions on what? Energy. You can be asked to calculate the kinetic energy of a question. You can be asked to calculate the potential energy of a question. So these two formulas are very important for us to know in what? In our mind. You have to have it in mind, the two formulas that are very useful in the calculations of what? Energy. So we are going to consider one or two applications of these two formula, and we are going to consider them using UTME question. All right, using UTME question. I believe I can clean the board so that we can move on to the applications of kinetic and potential energy. So permit me to clean the board while we move on to the next outline, which is calculations under kinetic and potential energy. Calculations under calculations on PE and KE, that is potential and kinetic energy. So let's consider some UTME question. The first UTME question, that's UTME question 2014. I'll read the question to our hearing, then I'm going to write out the parameters. An object of mass 20 kilogram, mass 20 kilogram, is released from a height of 10 meter, is released from a height of 10 meter. So the height is 10 meter above the ground level. The kinetic energy of the object just before it hits the ground. The kinetic energy, we are asked to find the kinetic energy of the object just before it hits the ground. Okay, we are asked to find the kinetic energy. And to solve this question, we have to relate kinetic energy and potential energy. Now, we are talking about a falling object, okay, and we are asked to find the kinetic energy before that object hits the ground. Take note, when the object was static or when the object was in position, it was having a potential energy. Okay, so when the object starts moving, it comes to have a kinetic energy. So we have to relate kinetic energy with potential energy. Potential energy will also be equals to kinetic energy, which is equals to mgh. And that is the formula for potential energy. And we already have the mass. The mass is 20 kilogram multiplied by the height, which is what? 10 meter, multiplied by g, should be taken to be 10 meter per second square. So we have g to be 10 meter per second square. Multiply this, you have 2,000. So 2,000 will be the what? The response. But this cannot be the final answer. You have to make use of your SI units. So what's your SI units? It is joule. Work is what? is measured, energy is measured in what? Joules. So we have 2000 joules to be the response of this UTME question. So, okay, we might not be chance to solve more questions, but I'm going to refer you all to the A1 Tutor app to practice more questions on energy. Okay, practice more questions on energy so that you can be conversant with some of the solutions and how to go about it. So the two formulas I gave you is what you're going to be using to solve questions under energy. Okay, so thank you for your time. We are going to stop here for today, and next class we continue to the next subtopic, which is what? Power. Stay online for the next class. Stay online for the next class. In few minutes time, they are going to have biology. So stay online so that you won't miss any part of this live session. Thank you and see you later.